Hello and welcome to this tutorial on how to build these linear actuators. These are available on MyMiniFactory.com for free. I've listed all the components, extra components down below. Some of them are Amazon affiliate links, so they will generate some advertising revenue for me if you click on them. I have marked which ones they are if you're not happy with that sort of thing. But yeah, I mean, these I use in my robotics projects. I mean, this one here is one currently being developed. Essentially, I'll put a pen in this and get it to run G code to draw stuff. So you can see just there is where I've got one there, another one situated there, and then one underneath there. So if I just run a quick test. I've locked that one out. That highlights an issue of these. You do have to control their range of movement. If you go too far, they will lock themselves out, which is why on the sides here, I've got rotor potentiometers. But when they do work, they move. When they do work, they work all right. They're a bit noisy. And hence these are two versions. On the back here, you can see just about there, that is a custom housing derived from this one, which has got the 12-volt motor, which is a lot more power to it. Whereas this one is 3-volt motor. A bit weaker, but it still does the job. If you've got everything balanced like an arm like this, it will move it fairly well, even with the weight of another one of these on there. So with all of that explained, let's move on to the different parts that need printing out, and then I'll talk about how they're assembled and then finally testing. So without any further delay, let's move on with that. And here we have all the pieces required for both the 3-volt and the 12-volt linear actuators. So I'll just go through all the pieces that will be required before we move into the workshop. A lot of the things I'll show, the extra pieces, I will have links below for each of them. There'll be a mixture of Amazon and previous places I've sourced things before, but hopefully they'll all be easy to get hold of components. The most important two things are the motors themselves. It's making sure to get the variant with these grooves on top on this particular profile. I have found them on Amazon. You can get them as packs of 10s. So that should be all right. These I know I have bought from Amazon, again with the groove style. You get these as packs of 2. Overall, the cost savings for this sort of style is quite a lot, considering some of the linear actuators about ranging from 30 to 50 pounds. But at the end of the day, if you just want one for hobby use, they're going to be pretty good. So other components, the M4 bolts, you'll be needing those. They have a nice hexagon style sort of shape to it, which is important for the fitting into the gear. The gears themselves have runners so that you can attach these curved pieces here, and then you'll have 3mm ball bearings such as there. So that'll be the thing. I just keep them in there. I mean, if the rest is just if you want to get that yourselves. Yeah, and of course, M4 bolts. You'll be needing plenty of those. Or you need one bolt, you need one nut and one bolt for one whole assembly. You'll also need a set of. I'm using a nylon M3 bolts and nuts for the fixtures. I haven't cleaned these up yet, so I don't know how well it'll fit. Oh, it does fit fairly well. Yeah, so you'll need one, I think, yes, yeah, you need 3 for the body. I mean, if you're going to buy a box set like that, you'll be able to work out the size of things. I think for the actual, I should have had these ready. Cross-contamination. These, oh, don't break it. Some of them will need a screw fit. I did try to make the holes have a nice clearance to them. But yeah, extract this. So as long as it can go through and you can attach a nut. That'll be the right length. So 2 of that length and 2 of the other one I showed a minute ago. Really, it's just down to how much of the thread you want sticking out the other side. So personal preference. As you can see from previous ones I've made, I'm running out of those of that particular length. Let's see, some sort of test cable as well. That will be handy for when you want to connect up and test the motors. I do have a dual H-bridge here. WD-40, that'll be used to spray on the inside, help everything run smooth. But before we assemble it, it's making sure that all the mess that the 3D printer leaves behind, yeah, a little bit on the inside, especially around the gears and teeth, we've got to clean that up, make sure that that's nice and smooth. So that, because this essentially sits on the bottom, but it does sit on ball bearings, but it's just to make sure nothing really scrapes. We've got on the inside here some rough edges that needs cleaning up, so it's all smooth, nothing can get caught. This is especially true if you're just using the 3-volt one. These do work okay, but you do need to make sure if you're moving an arm backwards and forth that it's nicely balanced, because this will run out of power quickly. Even though it's got a reasonable sort of gear ratio, it will lose power quickly. Yeah, this one will definitely have a decent amount of grunt to it, so that'll be good. 12 volts is that one, as per the name. Let's get to the workshop and get these cleaned up and assembled. So we've got a couple of things we're going to need. Got thin nose pliers, screwdriver. Handy things to have. Yes, I think I mentioned a rotary tool, sorted range of bits, up to you what you use, as long as you can get all into the nooks and crannies. So these are the main pieces. I think these are okay. I'll test those in a bit. These will definitely need working with, hence using thin nose pliers to hold them in place while you work with them. They need smoothing all the way around these edges here, because they've got to sit in these races here. So even now that doesn't fit at the moment till I've cleaned it up. There we go. And then of course, yes, let's see, so we've got gears to do, housings, and the motor holders as well, just cleaning up on the inside so the motors can sit a bit flush. Also these groove sections here, they'll need cleaning because these will be slotting in and acting as a bracket. Right, but let's get started. Right, let's start assembling. Now we'll assemble the 3-volt one first. So from before we'll need a bolt, a nut, 3 of those. Let's get those sorted. Actually, here we go. There's those, and 2 of the slightly longer ones. Again, when you're building these, you know, just sort of work it out yourselves what the right length is. And even if you want to use steel ones or whatever material, but I found the nylon ones to be nice and light. And if you're building a robot, then the weight is a factor. So we take this first housing here, make sure that it lines up the slot of there, and that should push in. When you fit the gear to the motor, make sure it's nice and flush and sits and can turn freely without any obstructions. So that's that first one. We then have this piece, this bracket, which then slides on into the grooves, and then that's that bit done. So, along those pliers, put 3 of these guides into the grooves on the base. Nice little bit of spacing. And this is where we get the ball bearings to fit. Don't send it everywhere. There we go. So one there. So the spacers, as I call them, are just to save on ball bearings. If you're feeling a bit sort of you've got enough money to go spending on ball bearings, then by all means fill that up, but I never made sure that it would fill equally, so to speak. Then we take one of these gears, the underside, that needs to be nice and smooth. M4 bolt slots in, then that goes on top, and that should run on there. Now of course, as I turn it, you'll see that it's not quite center. Try and get that as center as possible. It will cause things to wobble a fair amount. Then we've got the second set of spacers to go on the top. Now this, it does rattle a lot, make a lot of noise. This was pretty much just a get it working solution when I designed it. I'm sure there's much better ways of doing this, but for now this should serve our purposes. I mean, ideally, if you're only using like a weak 3-volt motor, how smooth you can get this mechanism to work is absolutely important. Otherwise, you're just sending all the power of the motor into turning the gears when you want it to actually be doing its job. Right, then the cover slides over the top, and then that should be those in place. Now, depending on the project, you can either insert them through the top or through underneath. I have forgotten to clean out the holes. That's one of the main things to try and do, is just get a nice little pointy scalpel and just run it in the holes, just to, mainly because my 3D printer is messy, so it always leaves lots of stringy bits. And that could just be down to the settings I've used or the age of the printer. As always, blame the equipment. That's the best way. So apply these down. I can usually get away of just holding my finger on the nut there and just tightening it up. Doesn't need to be crazy tight. Oops. Right, that's those first 2 in there, which I shouldn't have done. Right, let's secure this one in place, because that is supposed to sit and those are supposed to go on. So let's put this one in just to hold everything in place, and then I'll undo those first two. So this is what happens when I get caught up talking about what I'm doing rather than thinking what I'm doing. So apologies for that. Let's get oops, that's fallen out. It'll be a bit tricky because the idea is it pushes in, you've got to slot it in slightly so that it slides in. You may have to turn that a little bit to make sure the gears mesh. But once that's in place, got to make sure the holes line up. Now this could be where I need a longer bolt through. Oh, I'll be able to get away with that, that'll be fine, he says at the moment. Pushing that through will help just hold it in place. Yeah, as long as there's enough thread going, enough of the bolt thread to catch, should be okay. But I mean, if you're trying to use this in really extreme situations, then well, you're going to need a whole lot of strong of everything, really. This is just intended for light hobby work. So you can see the way that bracket on the back is holding the motor in place against this part here. The groove there should help with stopping everything turning. Now, we'll do this on the next one, but I forgot to spray that on the inside to help things run smoothly. But that doesn't sound healthy, so hopefully when you do this, you know, you make sure it's as clean as possible, because that should move a lot easier. Let's continue with the build. Now these have a groove just there for the nuts to slide in. Then take the other side and cement it. Now my 3D printer for some reason keeps printing those grooves at a slight angle, whereas when I check them digitally they're fine. So if I've got the piece here, now I've designed all of these larger holes for a Technique piece to fit in, so you can just put that in, hold it. Now let's get these through. Some of them are push fit, and it's just purely down to my 3D printer making things a bit too tight. Right, and then like any nut and bolt, you can see it shining on the inside there. You just attach it and just wind it on for as far as needed. Yeah, and the rest will be done in testing when we connect two wires up. But that is essentially almost complete, because I've forgotten these guides. So once that's wound in enough, you can attach one on that side and then one on the other. And this has been designed for the length of the nut, not the nut, sorry, for the bolt and the length of this. So this helps stop it spinning, but also means that when you attach this to something, it's held in line, whereas before without these, if I remove them, you've got quite a lot of play there, and that's just purely down to the design of the nut sitting in the gear. So having these in place really does help strengthen it up. Oops, helps if I get that. And you can secure it, glue it as much as you want. I try to get things so they're push fit and less using nuts, but yeah. So that is one linear actuator. You put power to the motor, it spins the gears and winds the nut in and out. There we go. Where should I put that? Let's put that on there. Now for the 12-volt motor. Now this one's going to be a bit tricky. Now the hole I've tried to design to be as push fit as possible, and I need a small hammer, possibly smaller. So that's pushed through to there, but we need, if we open that up a little bit, to push through a little bit more. Too far. We'll see how that goes. Yeah, too far. Let's go down a little bit. Let's use that as a gap. Let's see how that goes. Now this is going to be a bit of trial and error, especially since this is the first time I've done this one. I have a reasonable gap there, and the idea is that when it sits on there, you can just about see it poking through, but it shouldn't. You should still be able to have this fitted without that rubbing or hearing it rub. We'll see how it goes. This is the first time I'm assembling this one, so we'll see how it goes. And again, similar to that one, you've got this bracket on the back which slides on to hold everything in place. Let's see how that works. And W40. Try and, as I was going to say, try and do it gently. And get the other bolt. Again, nicely fitted. That could be better, but never mind. Grindy, grindy. Get the lid and attach. There we go. Now fish these pieces out. Right, this time remembering the order to do things, I secure everything in place with that one. Oops, come on. Right, assemble the nuts, push together. Might need to clean it out a little bit. We'll see from there. Right, that's that in place, and then it's just screwing it on. Of course, with the taller motor there, you may find it strikes the top a few times, but this is where having that bit wobbling a bit is actually quite useful in some strange way. Put that in place. Oh yeah, making sure it's sideways, it won't fit otherwise. And you can just, after a bit of force, you can push that fit in there. And then there is the 12-volt motor linear actuator completed. He says, looking at it just briefly, yes, that is complete. Right, well, let's head back inside and get these tested. And so we're back inside now. I've hooked up an 18-volt battery to my test system, and we've got the 3-volt motor one all line hooked up. And we can see it runs okay. I had to loosen it up a little bit, but yeah, that one works fine. Let's go across to the more powerful 12-volt. Let's hope I get it to go in the right direction. Whoop, don't cross them. It's the only problem of when they... There we go. Right. That is a lot more powerful. Yeah. So there we go. That is the 12-volt linear actuator and the 3-volt linear actuator. And hope you can find good use out of them. Thank you for watching.